Welcome, fellow developers. In your quest to develop cutting-edge applications, you may find yourself looking for a comprehensive profiling tool that can be used for a variety of target devices. Qualcomm Profiler is a performance profiling system that is used to measure and optimize application scaling across Qualcomm Technologies system on chips, CPUs, GPUs, DSPs, NPUs, and other IP blocks. We are going to guide you through the installation of Qualcomm Profiler and show you how your application's performance data can be extracted using the command line interface. We will also walk you through how your performance data can be visualized using the graphical user interface, or GUI. Qualcomm Profiler provides a comprehensive systems view and enables you to profile and identify performance bottlenecks on multiple targets, including Android, automotive running the QNX operating system, and IoT devices running Qualcomm Linux operating system. Supported hosts include Linux and Windows, and profiling can be accomplished directly on the target device or remotely using TCP/IP connection over a network. Qualcomm Profiler has 3 key features that make it an exceptional profiling tool. First, Qualcomm Profiler offers the ability to execute on or off the target device via the command line interface. This allows you to develop high-level automation solutions. Additionally, Qualcomm Profiler comes loaded with APIs that enable you to create custom profiling use cases embedded in your application. Automation APIs are available both on the target as well as connected hosts over TCP/IP. Another notable feature of the Qualcomm Profiler is the rich user experience and intuitive interface it provides. This enables you to configure and observe the profiling information visually. Qualcomm Profiler is available through Qualcomm Package Manager and Qualcomm Software Center, or QSC. We will briefly walk you through the installation of both Qualcomm Software Center application and the Qualcomm Profiler software. Then we will start viewing performance metrics on a connected device using the Qualcomm Profiler. Let's get started. Getting started with Qualcomm Profiler can be done in 3 simple steps. Install the Qualcomm Software Center desktop application, install Qualcomm Profiler, and set up the device. Install the Qualcomm Software Center desktop application from the Qualcomm Software Center web portal at the link on the screen. Once you have launched and sign in to the Qualcomm Software Center desktop application, go to the Qualcomm Developer Home to install the software Qualcomm Profiler. Select the latest version and click Install. The next step is to configure your device depending on your target OS. For each external device, execute the installation script for your connected target device. After the installation is complete, you can use a command line interface or a graphical user interface. We will review each in the following sections. The installation location includes some important documentation files, one of which is a PDF with information about each supported command and the supported metrics. Another way to view this information is through the Qualcomm Developer homepage. First, we will show how data can be extracted using the command line interface, or CLI. For this example, we are going to profile a device with Qualcomm Robotics RB3 Gen 2 platform by using the Qualcomm Profiler CLI, either via device shell or through the host PC for a connected device. To collect data on device, you can log into a device shell and export the installation paths. With the help command, you can display the list of supported commands. Now we can check which capabilities are available on the device using the capabilities command. We can view each of the available capabilities that can be profiled. For each capability listed, it displays the list of available metrics, each of which have more detailed descriptions in the documentation, the streaming rate supported, which is the rate at which data is streamed to the client in milliseconds, and the sampling rate supported, which is the rate at which the data is sampled from the device in milliseconds. This same command can also be executed through the host PC for a connected device. To accomplish that, we need to connect to the device. Figure out which IP address it can use for publishing. Configure the QProf server IP address. And start the server on the device once. We will show you the command line interface examples executed on device, and we'll briefly display the execution of each example through the host PC as well. First, let's look at an example of profiling CPU metrics. We can use the profile command with profile type as async, the capabilities name as listed earlier, profile time in seconds as 20 seconds, streaming rate in milliseconds as 200 milliseconds, sampling rate in milliseconds as 200 milliseconds, and the live option to output the data to the terminal. The default selected metrics can output a lot of data. If we want to display only the total CPU load information, we would select metric ID 4616. So we can add the metric ID list option and specify metrics in a space-separated list. For now, let's select 4616 to show the effect of how an arbitrary application can affect the values we are profiling. We will load an application to show how the CPU values increase as the application stresses the CPU. As you can see, the total CPU load values go up as we increase CPU load and comes back down as the workload goes down. Another metric available on this device is 4098 for NSP data, used for profiling the effects of intensive mathematical calculations. And if we run another arbitrary application, we can see the values start to increase and decrease once the application is terminated. You can also profile multiple capabilities at the same time. For example, CPU and CDSP. Note that if any capability does not support the provided streaming and sampling rates, the capability will default to the closest available rate. As you can see, each value has a timestamp, metric ID, metric name, value, and unit, but the subsequent parameters can change. For CPU, it has a core ID and name, for instance, while CDSP also includes instant average value and session average value. For further configuration of the profiling session, we can also make use of a config. First, we need to generate a single config through the QProf command that contains the capabilities we are including in the next profiling session. Once this is done, we can modify the resulting JSON. For instance, If you want to modify both capabilities to use the wall clock timer, we can set QTimer to false. And if we want CDSP to produce the raw data in the binary QP bin report, we can set metric query flag to 0. Once we have modified the config.json file, we can use it with the trace option flag to pass it to our profiling session, thereby changing the behavior. At the end of each command, we are provided with a path to the file that contains the last session's data. By default, the file is in the JSON verbose format. We can also select CSV format for a comma-separated file. Or trace format for a file that can be used with industry standard Profetto format. Now we can view this trace file through offline reporting in the Qualcomm Profiler GUI by opening the file. Another option is to view in Profetto, which is a production-grade open source stack for system profiling and trace analysis. And finally, with the same Qualcomm Profiler GUI we showed earlier to produce a QP bin file for CDSP for configuring the session, we can also use offline reporting to view that QP bin report in an easy-to-read format. Now that you have seen how to use the command line interface for extracting data on CPU metrics, we will guide you through the visualization of metrics using the GUI. Let's turn our attention to using the graphical user interface to view our data. We will view both CPU and NSP metrics. We can start the GUI by navigating to the appropriate folder on our machine and launching the executable. On Windows hosts, the GUI executable will be found at this location. Open the GUI using the Qualcomm Profiler shortcut. Note that there may be some pop-ups to allow permission for running the GUI executable and Node.js runtime environment when opening for the first time. You can just click Allow. Once the executable starts, it will open the main screen. The first time you launch it, there will be a shortcut pop-up card that appears, which features the following main options: open a workspace, connect to a device, and analyze existing data. These options are shortcuts to different pages of the application's main workflows, which we will discuss in more detail later. For now, let's cover what's on the homepage. From the toolbar, you can reach any of the main pages by clicking on Options. On the left side, under the Welcome section of the homepage, there are also shortcut options which are available on other pages for workspaces, devices, and data analytics. You can opt to be redirected to the workflows available on the other pages by clicking on these options. Under these options is the Frequently Asked Questions section. You can click on any of these options to open the documentation in the application for information on the Qualcomm Profiler GUI and its use cases. In the middle of the homepage, you'll see a section for workspaces, devices, and recent data files. Under these sections, there are recent entries, if any, for each section. These entries are cached locally in a configuration file to allow users to easily reuse saved configurations. Clicking on these entries should either open a saved workspace, connect to a saved device, or show a recent data file. Devices connected to the host machine via USB are discovered and shown as a card. If you want to clear these entries from the application cache, you can either do so on the GUI with the Clear option or by deleting the configuration file stored on the system. On Windows, it is located here. Note that clearing these workspace entries won't delete the workspace file on the local file system. You will still be able to open a workspace file, and the connected devices will show up as a card even after removing all cached devices from the system to allow you to connect to it quicker. Let's take a deeper look at the workspaces, which are meant to represent configurations that can be easily saved and reused. You can reach the Workspaces page by clicking on the Workspaces tab available on the home page. You can save multiple workspaces with or without device configuration, as well as selected capabilities and metrics for profiling. This will offer easy reuse for profiling needs as desired. On the Workspace page, you will have several options for workspaces, as well as recent cards of saved workspaces on a host machine, if any. Clicking on any of the Workspaces cards will load the saved workspace and its configurations. Selecting the Open Workspace option will open a File Explorer window and allow you to select a workspace file saved on the machine and load it into our application. Selecting the Create a Workspace option will open the application to a step workflow where you can create and save your own workspace to the host machine. You will have to specify an existing device to save, or alternatively, create a new one, and go through the rest of the configurations. Once the configurations are set, you can select Save Workspace, and a workspace file will be saved locally to your machine to be reloaded into the application for future use. Now let's go over the Devices page. You will reach the Devices page by clicking on the Devices tab available in the toolbar. On the Devices page, you will have an option to add a device or select any recent devices to load into the application. Selecting the Add a Device option will open a pop-up window that allows you to specify a name and platform type for the device you wish to connect to. Once these fields have been filled, selecting the Connect button will take you to the connection configuration page for profiling. On the left-hand side of the device page, you must enter the IP address and port of the TCP connection that was set up on the device, and then click Connect. Once you have configured a device and a connection has been successfully established, you will need to select a profiling type. Live profiling and DSP performance are the two profiling types currently supported. Let's explore the live profiling option. Once the live profiling view opens, you will be on a page for profiling configuration. There are several options for profiling available. It's important to note that there is now a left side navigation bar present, which is shown on the application when you successfully establish a connection with a device. You are currently on the Device section, which is the page that allows you to configure options for profiling. The other left navigation bar will be addressed later. Similar to the Create Workspace workflow, you can select the Save Workspace option, which saves the current configuration to the host system for a quick setup in the future. If desired, you can choose to close this current workspace. This will not clear the workspace file from the system or delete it from the application's saved cache. This acts as a way for you to start from a fresh workspace setup in the same session of the application. You can now configure capabilities and metrics you want for profiling purposes. The application will display the capabilities of the system on the first tab called Metrics. These capabilities are auto-detected from the device system and provide you with the capabilities available for profiling. Within the selected capabilities, there is a set of metrics associated with each one of these capabilities. You can select a subset of metrics within a given capability to capture data for those metrics during profiling. For this example, let's select the following capabilities and metrics. Click on the CDSP Capabilities panel to expand the selectable metrics. You can use the scroll bar to the right of the expandable panel to browse through the metrics that are supported as part of the CDSP capabilities. You can also use the search bar at the top of the capabilities table to search for all the metrics that contain specific text, for example, utilization. Let's select QDSP6 utilization, HVX utilization, and HMX utilization metrics. We will also expand the CPU capabilities panel to see the available metrics and scroll down to select the CPU total load metric for this profiling session. You can also switch over to the Statistics tab, which shows which services are available to get more information about the connected device. Now we are going to expand the CDSP stats capability and click on all the services that are shown. You can also configure the profiling options within the Profile Settings window by selecting the Profile Settings option in the bar. You can configure options such as delay profiling, profiling duration, and streaming rate for both metrics and statistics. By default, the application also selects the Save to File option, which will save a .hdf file for profiling data received so you can view in the application later. You may also select and deselect the Save to CSV option, which will also save profiling data to a CSV file format for the profiling session. For this example, we will check the Save to CSV option and set the profiling duration to 2 minutes. Once the capabilities and profile settings configuration are complete, you will begin profiling the system by clicking the Start Profiling button. Then you will be directed to the Profile view, where you will see a graph of the chosen metrics, as well as the data associated with those metrics. Let's look at the effect that our sample application metrics have on the profiling charts. As the application increases the load on the NPU, you will see the values of the Qualcomm Hexagon Matrix Extensions, or HMX utilization, and Hexagon Vector Extensions, or HVX utilization charts go up. As the test approaches completion, you can see the values gradually decrease back to normal levels. When I run the application that increases the CPU load, you can see the CPU total load go up on the chart as well. If you switch to the Statistics tab in the Live view, you see information returned by the services selected from the CDSP capability. You see the core clock list, number of hardware threads, as well as information of the processes running on the device. You may also choose to press the Stop Profiling button in case you want to stop the profiling before the pre-selected time has expired. Once profiling is done, you can go back to the Devices page to choose a different combination of capabilities and metrics for profiling purposes. Using the left navigation bar, you can also select the data files to see the recent saved files of your profiling sessions. In each entry of the table, on the right side of the File Explorer view, in the Data File section, you can select the folder icon, which opens the File Explorer of the file's location, the eye icon, which will load the file's stored data into the application view for analytics, or the spreadsheet icon, which will load the corresponding CSV file. This requires that the Save to CSV option was selected in Profile Settings. You can also opt to open different data files aside from the ones in this table by opening the Data Analytics page. We will now switch to a different profiling type by going to the Common Settings panel in the left side of the device screen and click the Change Settings icon. Click on the DSP Performance options and confirm. You will be taken to the Devices view displaying the capabilities that support DSP performance analysis. For these capabilities, relevant metrics are enabled automatically upon selecting a capability and configuring it according to the exposed parameters. Let's select CDSP capability for profiling with the default parameters in place. Then click on Start Profiling and go back to run the DSP stress test on the device. Once the test on the device completes, click the Stop Profiling and wait for the data to be processed. Once the data is parsed, the DSP performance report loads in the data file view. Here we can see a summary of the HVX and HMX activity, active thread metrics, bus, core, clock, and heat metrics, all displayed in both a tabular format and in charts. You can reach the Data Analytics page by selecting the Data Analytics option in the toolbar. On this page, you have an option to open a file or select one of the files from the recent table view. Clicking the Open File option will open a file explorer for you to select a file on the host machine to open in your application. You are able to select different file types to be loaded into your application. You can choose to open a .hdf file or a .json file that is typically collected through CLI and is Perfetto compliant. Now that you have seen how to extract and visualize data using Qualcomm Profiler, we are certain you will find it useful in your application development workflow. As thousands of developers have already discovered, this tool will help you identify metrics needed to optimize your application and to significantly improve the user experience. Please visit developer.qualcomm.com to find other useful tools for application development.